Hola oyentes de Tumble, soy Nuria. Estamos trabajando en un nuevo episodio de Tumble en español y más contenido para ustedes. Pero mientras tanto, queremos compartirles este episodio en inglés. Este episodio surgió de una pregunta de un oyente de Tumble en español, Jerónimo.
Hola, mi nombre es Jerónimo y soy de la Ciudad de México. Mi pregunta es, ¿qué es la materia oscura? Yo creo que la materia oscura es como una fuerza oscura. No sé cómo los científicos lo pueden medir.
Gracias, Jerónimo, por enviar tu pregunta. Si tú también tienes una pregunta sobre ciencia que quieres que respondamos en Tumble en español o en Tumble, nos puedes escribir a tumblepodcastforkids@gmail.com. Tanto Tumble como Tumble en español son posibles gracias a las donaciones de nuestra comunidad, de nuestros oyentes. Si quieres apoyar podcasts para niños y toda la familia sobre ciencias, haz tu donación en Patreon y busca Tumble Podcast for Kids. Muchas gracias y hasta pronto. Aquí les dejo con el episodio.
Hi, I'm Lindsay.
And I'm Marshall. Welcome to Tumble, the show where we explore stories of science discovery.
Today we're asking, what's dark matter?
I think that's easy. You just take some matter, put it in the closet, and turn off the light. Then it's dark.
That's not what it is. Dark matter is something that we can't see, but it shapes the universe in ways that we want to understand. In this episode, we'll be traveling into a laboratory deep within a mountain to try and find it. Today's question comes from a bilingual Tumble en Español listener.
Hello, my name is Jerónimo and I'm from Mexico City. My question is, what is dark matter?
Oh, I'm excited about this one. I don't really know what dark matter is either, and maybe nobody does. I mean, what is matter? Like the light kind, anyway.
Well, matter is basically stuff. Anything that has weight or takes up space is matter.
Sure.
But scientists think there's much more matter in the universe than we can see. They estimate that 85% of all matter is dark.
Oh, well, so what's dark?
Well, let's hear Jerónimo's idea of what dark matter might be.
Yo creo que la materia oscura es como una fuerza oscura.
So he's saying that he thinks dark matter is like a very dark force, kind of like Star Wars. It's like the dark matter side of the force, the one we don't want to run the empire.
Well, that's kind of a sci-fi answer. But what's the real science answer? Let's ask our listeners. What do you think dark matter is? And how do you think scientists would find out? Think about it, because we'll be back with a scientist who is searching for dark matter in a way you may not expect. To get an answer for Jerónimo, I called up Álvaro Chavarría. He's originally from Costa Rica, but now he's running a dark matter detector in a lab deep underneath a mountain in the French Alps. And he told me it's kind of fun.
It's hard to get started, but once you do, it's just super enjoyable.
I mean, that does sound like a really cool job, but you're talking about a lab deep under a mountain? I mean, that sounds like a movie villain to me.
Well, it kind of does, but this is something that scientists are doing all around the world. There are actually quite a few underground labs.
The one where we have our experiment is called the Modan Underground Lab.
The Modan Underground Lab is in a road tunnel between France and Italy, under the Alps mountain range that borders the two countries.
And in the middle of this tunnel, there is this cavern where the laboratory is.
People driving between the two countries might not notice the big metal door in the middle of the tunnel. It's large enough for a truck to go through, and there's a person-sized door next to it. only people working in the lab go behind those doors.
Are you kidding me? It's like a secret under-mountain lab with a secret door that people drive past without knowing about it, and he's studying dark matter? What is going on here?
I mean, a lot of people think like that, yeah, but it's not.
Sure, Alvaro, but why is it underground? Just to make it more cool? Or are you hiding something?
No, in fact, Alvaro's going to take us behind the doors to share how he's trying to discover the secrets of dark matter.
Okay, but why is he doing it underground?
It's underground because that's where dark matter detectors have their best hope of finding dark matter.
If these instruments were to be placed on the surface of the Earth, then we would have cosmic rays that would interfere with it.
Okay, so this is probably the most sci-fi tumble episode ever. He's in an underground lab at the bottom of a mountain in a secret tunnel that's trying to escape cosmic rays. So how do the cosmic rays interfere, and are they coming from alien spaceships? That's what I want to know.
No, cosmic rays are actually everywhere. And Álvaro says that they could confuse scientists looking for dark matter because to the detector, the two things might look similar.
So to stop this, then we go deep underground.
Cosmic rays can't travel deep enough into the Earth's crust to reach the lab. But scientists believe that dark matter flows through the Earth.
Oh my gosh. Okay, so it's like an escape to a secret lair where only dark matter can be found.
I feel like you want this to be evil, but it's not. Before we go past these doors to enter the lab, let's get a few things clear about the search for dark matter.
It's evil.
No.
Oh, okay.
Astroparticle physicists like Álvaro want to understand everything that makes matter so we can understand how the universe works.
So it's a natural question to ask, what are the particles or the little building blocks that make this dark matter?
Okay, so I know matter is like all the stuff that we see and interact with, and smaller things like atoms make up matter.
Yep, you got it. Particles are the tiniest unit of matter. For example, light is made up of particles, but there's many other types of particles that we can't see.
And in our case, specifically to what we're talking about today, dark matter or hypothetical dark matter particles.
What does he mean, hypothetical dark matter particles? What does he mean by that?
Good question. Hypothetical comes from the word hypothesis. And there's a hypothesis or scientific idea that these particles exist. But that idea hasn't been proven yet. And that's exactly what Álvaro is trying to do.
Okay, so what is the idea of this hypothetical dark matter? I think that's what Geronimo wanted to know, even if we can't say for sure what it is.
Yeah, here's how Álvaro explained it.
So Geronimo is right that there's some component of it that is related to force and something that's related to it being dark.
Oh, okay. So is that how Luke Skywalker makes rocks float?
No. Let's break down what Álvaro means by dark force a little more. First, with force.
So when an object has matter or mass, then it exerts a gravitational pull on other objects.
Okay, so what he's saying is that a force is something that pulls on something else.
Yes, when it comes to matter and gravity.
The dominant force in the universe is gravity.
All right, finally, we're talking about something I know what it is. Gravity. Why what goes up must come down.
That's a basic definition. Gravity's force pulls objects together, keeping our feet on the ground on Earth and keeping planets orbiting around stars in space.
But it looks like there is an additional source of gravity or something that is exerting a force on celestial objects that we cannot see, and it is dark.
Ah, so that's the dark matter, the mysterious force. Geronimo was right.
Right. And also, dark matter has been invisible to all of the telescopes and tools we usually use.
And that is what we call the dark matter.
But if it's invisible, how do we know it's there?
We do something called infer. To infer something means that we understand that it exists because of the effects it has on something we can see.
We know its existence from the pull it exerts on all celestial objects, but we just can't see it.
Okay, I think I get it. So we can infer or understand that dark matter exists because we know it's doing something to galaxies.
Exactly. Dark matter is the theory that explains what's happening. Álvaro and other scientists are trying to prove its existence by searching for dark matter particles.
Okay, I think I get it. Well, so why is Álvaro looking for dark matter particles in an underground lab? Wouldn't you want to be, out in space if they're controlling how galaxies move? Because last I heard, that's where galaxies are.
Well, we're in a galaxy, and by that logic, dark matter should be here on Earth.
Since the dark matter is in the galaxy and we're moving in the galaxy, then there's sort of hypothetically this wind of these particles that are blowing through the Earth.
Okay, a hypothetical wind. Feeling a hypothetical breeze in your face while you drive a hypothetical sports car.
Dark matter particles could be swirling around us as we speak, but we don't know. To find them, you need to detect them.
And so what we tried is to develop instruments that can sort of sense the little particles in this wind.
So like a special kind of piano or something?
I'm pretty sure a special piano won't work.
Right. It would have to be like something you blow into, like a brass instrument.
A woodwind. Yeah.
The dark matter oboe.
Yeah. No, it's a dark matter detector. Let's take a quick break. And when we come back, we'll open the doors to the lab to see it for ourselves. We're back. So we've learned what scientists think dark matter might be and why it's important in the understanding of our universe. And we were right at the door to enter the Modan underground lab.
At the middle of the tunnel, suddenly there is a door, a big door.
All right. Well, so do we get to go in now?
Yes. Once we're past the doors, the lab opens up into a large multi-story room. The walls are rock, of course, and there's also no windows. There are offices, a lunchroom, and bathrooms. And the lab is filled with equipment for various high-tech experiments, including Álvaro's dark matter detector.
Are there also large chairs where the lab director can spin around once he's ready to reveal his plans to his underlings and then laugh maniacally?
No, that is not a feature in this regular lab that just happens to be underground.
Underneath a mountain, I should add.
Okay, but now we have to do something special to actually get to where the detector is.
Now, if you want to work on the instrument, you have to access the clean room.
A clean room? Does that mean all the other rooms are dirty? They've got clothes and dust all over them?
Not exactly, but clothes and dust do have a lot to do with it. We pick up a lot of dust particles on our clothes and our shoes as we go about our days, and the detector can't have any stray particles coming around. So we need to change into special clothes before we can go in.
To access the clean room, you go through something called the gowning room, which is the space where you transition from wearing your everyday clothes to clean room gowns, which, sometimes called bunny suits, right?
Bunny suits? So now I'm imagining a bunch of Easter bunnies walking around. Are they clean? Easter bunny suits?
No, these are a little bit different. They're kind of like scientist onesies. They keep dust off of you.
And then you put this coverall over you, this white coverall.
Next, we cover our hands.
And then you put multiple layers of gloves.
And we change our shoes and put another layer over them.
Put also booties on top of your clean room shoes.
And when we're all covered head to toe, we take an air shower.
Like a little capsule that you walk in. It blows air on you to remove all residual dust.
Ooh, an invisible shower to find invisible dark matter.
Yep, and finally, we're ready.
You go inside.
All right, well, so now we're inside the clean room with the dark matter detector. What does this actually look like?
From the outside, it's big and bulky and encased in a material that shields it from outside particles. It's kind of the size of a refrigerator, and part of it acts like a refrigerator too. The experiment itself sits inside something called a cryostat,
which is a vessel on which the things inside are cold.
Why does it have to be cold?
Well, it's because, like cosmic rays, heat could interfere with the experiments.
Huh.
The detector is also covered by an interior shield made of lead, designed to keep the other types of particles out. And what all of that is protecting is a series of very delicate, very sensitive sensors.
So, but how do the sensors work?
Well, they're actually not too different from some of the technology we use every day.
A very simple example, which is related to what we do, is a camera.
A camera has a sensor inside designed to detect light, which is captured in tiny squares called pixels. Álvaro's taken a more complex version of that and redesigned it for dark matter.
And so the idea is that if you were to have one of these dark matter particles have a collision with the atom in one of the pixels, then you would get it to light up like a signal right there.
Oh, wow. So it's like they're not forcing the particles to collide. They're just sitting and waiting for something to just happen. And the sensors will let you know if it happened.
Yeah, and the chance that something will happen is actually very low.
Because interactions are extremely rare, you have to collect data maybe for 1 year to see probably one dark matter particle give you a signal in one of the pixels.
Wait, you have to wait 1 year for just one dark matter particle? Like, what's up with that?
Well, scientists assume that dark matter is so hard to find because it doesn't really interact much with normal matter. So it's not likely to come across the sensor very frequently. And that means the sensor is finding a lot of nothing.
So once the device is installed and it's running, all it's doing is taking pictures. Of nothing, right? Because it's dark.
So this is, again, I'm wondering, did they try turning on the light? I feel like that would help.
Marshall, it will not help.
Okay.
The idea is that this device would take the first ever snapshot of a dark matter particle.
Well, that sounds to me like it would be totally worth it. So has Álvaro gotten that photo yet? Has he found dark matter?
Well, he turned on the detector.
And we run for a few months and we didn't see anything.
Okay, so nothing. Well, I guess you have to run it for a year, and he's only been running it for a few months, so you probably didn't expect to find anything.
Exactly. This was a test run.
We're hoping to run with 10 times as more devices for 10 times as long, not months, but years.
With more devices and more time, they'll have a better chance of finding dark matter. And it will also help them test the many theories of what dark matter is.
And what remains will be ruled out, or we will discover the dark matter in the next year.
Oh, okay. So I guess the possibilities are either A, he crosses off all the theories that exist, leaving nothing, or B, he finds a dark matter particle, which would be pretty exciting. But what if he crosses off all the theories and there's nothing left?
That's the really big question.
And then there is the probability that we got everything wrong and dark matter is not even there, and the solution is an entirely different thing.
Wait, what? So he could find that dark matter doesn't even exist and we just have light matter?
Yes, that's a possibility. Álvaro is working on his detector because he believes that he will find dark matter this way. But the idea that someday someone could turn everything we think we know on its head, that's also exciting to him.
Which should be very encouraging to young people, right? The fact that we have this big puzzle, and maybe we just need a revolution to figure out really what's going on.
A scientific revolution started right here in an underground lab. The plot gets even more sci-fi.
It doesn't have to be sci-fi. This is how science works. It's how we've come to understand what we know about the universe, and maybe what we'll learn in the future. So let's ask Geronimo what he learned.
After listening to the episode, the biggest thing I learned is that maybe dark matter doesn't exist.
It'd be kind of a bummer if it didn't exist, like build that whole underground lab for nothing.
I agree. But scientists have found lots of other kinds of theoretical particles, so I feel like they're gonna find what they're looking for. And also, that wasn't Geronimo's only takeaway from this episode.
Dark matter is a force that we don't see, but it's all around us. I thought, how could I measure it? Thank you so much.
Well, thanks, Geronimo, for your excellent question.
Yes, and we'll keep covering these dark science matters.
We will explore the darkest depths. Now that you've learned how Álvaro searches for dark matter in an underground lab, design your own underground lab and experiment in what kind of mutants will you create there.
Not mutants.
Well, you never know.
Think about the kinds of science questions you would want to study underground. Then design a blueprint for your experimental device and where it would be. Would your underground lab have any special features? What would it be named?
Send us drawings or descriptions of your underground lab to tumblepodcast@gmail.com. We would love to see them.
Thanks to Dr. Álvaro Chavarría, Associate Professor of Physics at the University of Washington in Seattle and Detector Lead for the DAMIC-M International Collaboration. Special thanks to Geronimo for his question and recordings.
Don't forget you can listen to Tumble in Español just like Geronimo does anywhere you get your podcasts. If you want to learn more about physics and the universe, check out our episode, ¿Alguna vez no hubo nada? Or Was There Ever Nothing? On both our Spanish and English podcast feeds.
It's super fun to listen in both languages.
Also, if you love what we're doing and you want to help us support the show, join our Patreon. When you join at the $5 level or higher, you'll get ad-free episodes, special chances to be on the show, and of course, the birthday shoutouts, which are coming up in just a minute when you sign up at the $5 level or higher at patreon.com/tumblepodcast.
Elliot Hajaj is our assistant producer. Sarah Robertson-Lentz is our managing editor and created the episode art. Mixing and mastering is by Gary Calhoun-James. We had special help on this episode from Nuria Netz. I'm Lindsay Patterson, the executive producer of the show, and I wrote this episode.
And I'm Marshall Escamilla, and I make all the music for Tumble. Tumble Science is a production of Tumble Media. Thanks for listening, and stay tuned for more stories of science discovery.